This video is on organic functional groups. These are different groups or substituents that can be on your hydrocarbon other than ones we've already talked about. So we're going to talk about some more in this video. So hydrocarbons in general are fairly unreactive. Besides combustion, there's very little that they will do. For an organic molecule to be reactive, it needs something additional. So that's where these functional groups then actually make them more reactive. So this site of reactivity is where what we call the functional group, and that determines the chemistry of a molecule. The simplest functional groups are ones we've already talked about, alkanes and alkynes, so the double and triple bonds. Other functional groups contain elements other than C or H. And when we draw these and kind of go through their generic formats, we're going to use the letter R, and we'll do this with, like, here is R, here's R prime, here's R double prime, and R will represent any chain, any length chain of carbons. Okay, and if I have R prime, it's just going to be a different carbon chain. Okay, just to give us kind of just a generic starting point. All right, so these are the functional groups you're going to need to know. You're going to have to be able to identify them. Later videos will discuss how we name them if you don't already know, if they weren't already covered. And there are flashcards, or making them would also be a good way to do this, but there are flashcards as a Quizlet in Schoology. So an alkene is, we already know, when you have a carbon-carbon double bond, and you can have any other chain or hydrogen on either side. So the simplest would be like a CH2, double bond CH2. All right, an alkyne is when you have a, when you have a C to C triple bond. Again, you're going to have some sort of chain on either side. This would be like a CH, triple bond to a CH. Okay, so these are ones you already know. So alcohol. So here's a new one. An alcohol is also known as a hydroxyl group. Okay, and this is when you have a hydroxide. So you have some chain with a hydroxide on it, so an OH group. So our simplest would be CH3OH. All right, an ether. So not ether, it's an ether. An ether is when you have an oxygen in between two different carbons. Okay, so the simplest one here would be if you have a CH3 to an O to another CH3. Because remember, oxygen bonds twice. It has those two valence electrons that are single, that are lone. And then it has two lone pairs that don't bond. All right, so ether is the O in between. A haloalkane, we've actually discussed already. This is when you add a halogen. So I'm going to use X is going to be my halogen. So fluorine, chlorine, bromine, iodine. So this would be any carbon chain with your halogen. So this could be something like CH3 with a fluorine, a chlorine, a bromine, whatever that may be. Let's just put fluorine just as an example. All right, an amine, am like this, and you're going to see it come up later, means nitrogen. So amines are going to be when you have some carbon chain connected to a nitrogen. Now, what can vary is what your nitrogen is also bonded to. So nitrogen bonds, if you remember, 3 times. It's got a lone pair and then 3 single lone electrons. So if it bonds to this carbon, its other ones could be H's like this, okay? Or you could have it to an H, and then it could be another carbon group. Or it could be bonded to 3 different carbon groups. Oops. Sorry about this. Like this. All right, so this would be something like if you had a CH3 as your R bonded to an NH2, or a CH3 bonded to NH and then like another CH3 group, or a CH3 and then an N and then 2 CH3s attached to that. All right, next one is an aldehyde. So an aldehyde is when you have a carbon double bonded to oxygen on an end carbon. So here's your chain, here's your carbon on the end, double bonded to an O. Now it has, right? So like, kind of like a terminal carbon at the end of a chain. So your simple one would be a CH2. Actually, I don't have that written down. Sorry. CH2 to an O, and then to a CH. Okay, so here's your end. All right, a ketone is very much like an aldehyde. So these are similar in that they both have what we call a carbonyl group. So a C double bonded to O is what we call carbonyl, but they're in different locations. In the aldehyde, it's on the end. In the ketone, it's in the middle. So chain, carbon, other side of the chain, and here's my double bond to O on a middle carbon. So this would be like a CH3C double bonded to O, and then another CH3 would be our simplest one. All right, so a carboxylic acid is when we have a carbon double bonded to O, and then bonded to a hydroxyl group somewhere on the end of your chain. So I like to think of it as a carbonyl and an alcohol combined. So carbonyl plus alcohol, right? So here's your carbonyl, here's your alcohol. So our simplest one would be CH3COOH, which would be acetic acid. Actually, that COOH is your carboxylic acid group. Okay, so an ester then is, I like to think of this as a mix of our carbonyl and our ether. So this is, you're going to have your R to your C to an O, right, to some other carbon. Okay, so there's the ether part, but then your C also has a double bond to an O. So here we'd have CH3, COO, CH3. So double bonded to one O, single bonded to the other. All right, an amide, remember that AM part means nitrogen. An amide, I like to think of as an amine plus a carbonyl. So carbonyl plus amine. Amine. Careful there, one letter difference. So this would be like if I had R to C, so here's my carbonyl, and then here's my amine. And really, just like over here when I talked about amines, these don't have to be H's. They could be other carbon groups. They could be R's. All right, the last one is a nitrile. Oh, hold on, let's go back to here. This would be like a CH, oops, go back to here. Okay, this would be like a CH3, CO, right? There's your CO double bond, NH2. And our last one is adding a cyanide group. So remember we talked about polyatomic ions, C triple bonded to N, then on the end of some chain. So your simplest one here would be CH3 with a CN. That cyanide group is a nitrile group. So these are the functional groups you're going to need to know. You need to be able to recognize them in larger molecules. So flashcards are really going to be helpful here, and we will do lots of practice.